the terms for estimates of location, which is basically location means location on the graph where we plot all the points, and dispersion, which basically means how spread the data is on the graph, right? And why are we discussing about this? I've mentioned something for you guys as a comment here, right? So when we solve business problems using data, right, we may need to explore and understand the characteristics of data in question, which is called the EDA. EDA means exploratory data analysis. Now, whenever we'll solve problem, you know that all the things that we discussed yesterday, they would require us to solve some problems. And to solve those problems, what do we have to do? We need to look at the data. Now, looking at the data, it's not going to happen, right? That I have a problem, I bring you on that problem, like, I want you to solve that problem, and to solve that problem right away, I give you the data and I ask you that give me a solution in 1 hour. Will it be possible? When I give you some data, you will need to understand that data. You will need to explore the data. You'll need to see what the data means in the first place, right? That's why data scientists are needed fundamentally, so that they can understand the huge pile of data that's available and make sense of it. So to understand that data better, there are some parameters which are the measures of central tendency, which become very, very useful. So to figure out the location of a particular point or a data point, there are 4 important parameters in statistics or from a data science perspective: mean, median, mode, and outlier. I'm sure that most of you already must be knowing probably about mean, median, and mode, right? And then dispersion has again 2 parameters. Dispersion is more like spread of your data. It has 2 parameters, important terms: variance and standard deviation. And variance and standard deviation are related to each other in the sense that variance is the square of standard deviation. Now, each one of these location parameters, right, for central tendency, they're used in different contexts, right? So for example, mean is preferred when the data is balanced or when data is not skewed. What do I mean when I say data is not skewed? Look at this visual that is being shown here. Do you understand? What do you call this plot that you see in front of you? These kinds of plots, I'm sure you guys all must be imagining these plot when we talk about statistics, right? What is this plot called, where frequency is plotted on the y-axis and then x-axis as something? Now, what was I saying? That mean as a measure of location, that if you consider that mean is the central tendency measure that you will go with, it is only going to be useful, it is saying, when the data is balanced, which means that data is like this, the middle graph. It's a symmetrical data. On both sides of the mean, there is equal data. And in this case, you can say, yes, that mean is a good measure of central tendency of the data, because mean is telling you where is the data centered, around which value is the data centered. If there are 10 people in a class whose age is between 18 to 24, you would know that the average age or the central tendency is going to be what? It is going to be the sum of all the ages divided by number of people in the class, right? The mean. But it is only going to be possible, that mean is only going to be correct when the data is a little bit symmetrical, because otherwise it is possible that everyone in the class is in the age group of 1 to 10. And let's say there are 10 students in the class, 9 students are less than 10 years of age, right? And one student is like this old fellow who's doing night school and he's 80 years old. There are 10 people. Let's say 9 people have age less than 10 and one person has an age 80. Now what will happen? If I take mean here, it is not going to work out. The mean will not give me the right idea, because if 9 people have age less than 10, then I know that sum of all those 9 people's age is going to be less than 90. All the 9 people have total age less than 90, and then that one person has an age 80. Now, if I sum all of those up, and if I calculate the average age, let's say 90 plus 80, and I divide it by 10, what is the average age? 90 plus 80 divided by 10 people, 17. Now, average age is 17 of that group, whereas what is the reality? That 90% of the group has age less than 10. Is this the right representation of the central tendency of this data? So in this case, where I know that 9 people have age less than 10 and only one person has age that is very huge, which basically means a skew, right? Skew. What does that skew mean? That very few people have a high age. This example that I told you, right? That only very few people have a very high age. Which graph will represent this example? The skew here in this case is going to be positive skew, because this graph is going to be skewed to the left, right? It's skewed to the left. The peak has shifted too much to the left because most of the people have values on the lesser side on the x-axis, and very few people have higher values on the x-axis. And that's why you see in the positive skewed case that the mean might be 17, the median might be 9 in the positive skewed case, right? And that x where it is becoming like 0, that point might be 80, right? Somewhere far down here in the positive x-axis direction. So what you understand is basically median is preferred when there is skewness present in the data. Mean is preferred when there is balance in the data.